What we're doing in this section, you need to remember all of the fundamental identities that we've covered in the past. This is not new information, it's the same information that we've done before. And even the first example problem is similar to what we have done in the past. So if cosine of theta is 5/8 and theta is in quadrant 4, find each function value. So in order to find the sine, we need a fundamental identity that relates sine and cosine. And we know that that's the Pythagorean identity. Here I just did 1 minus 25/64, so that's 64/64 minus 25. That gives me 39/64. Taking the square root of both sides, it's the negative square root of 39 over 8. The reason that I know it's negative because cosine is positive in quadrant 4, sine is negative. To calculate the tangent, I'll just take sine over cosine. I just copy dot flop and get negative square root of 39 over 5. The last one asks about the secant of negative theta. Well, remember that secant is just the reciprocal of cosine, so the secant of theta is 8/5. And if we look on our notes at the negative angle identities, we see that the secant of negative theta is equal to the secant of theta. So it's just equal to 8/5. On this problem, we're being asked to express tangent in terms of cosine. What that means is that when I'm all done, the only trig function that should be in the expression is cosine. So to start this, I'm first going to express tangent in terms of sine and cosine. So there's sine of theta over cosine of theta. Then what I'm going to do is I'm going to re-express sine in terms of cosine. And the way that I do that is I look at the Pythagorean identity. And essentially, I solve it for sine. Take the square root of both sides. Please do not forget that you need to include plus and minus. Now that I've done this, I can substitute all of this information in place of sine. So when I do, I get that the tangent is equal to plus or minus square root of 1 minus cosine squared over cosine of theta. And now I have expressed tangent in terms of only cosine. So if you notice, there's only cosine here.